All right, so let's talk about databases. Ever stop and think, why do we even need them? I know, it sounds like a super dry, technical thing. But trust me, the real story here isn't about code at all. It's actually a story about solving, well, complete and utter chaos. So let's dive into the massive problems that basically forced us to invent this whole thing in the first place. So at its heart, what is a database? It's really just an organized collection of related data. The easiest way to picture it, just think of a perfectly organized, super smart digital filing cabinet. And for our story today, let's pretend this filing cabinet belongs to a college. So, what's inside this college's digital filing cabinet? Oh, just about everything. You've got student names and addresses, all the fee payment details, who's enrolled in what course, faculty info, grade records, the whole shebang. It is a mountain of super important data that has to be managed perfectly. But before we had this neat and tidy solution, things were messy. I mean, really messy. To really get why databases are so brilliant, we've got to go back in time. We need to understand the absolute mess they were designed to fix. So let's talk about the old way of doing things, an era I like to call file chaos. In this old system, every single department kept its own separate records. The data was all stored in these individual, completely disconnected files. We're talking about basic text files or spreadsheets, one for the admin office, another for the bus service, one for the science department. And the key thing, they didn't talk to each other at all.
So, for example, the main student administration office might have a file that looks something like this. It's got the student's name, their roll number, their address, and their fee status. Seems pretty straightforward, right?
But then you've got the bus facility, and guess what? They have their own separate file. It also has the student's name, their roll number, and, hang on a second, it also has their address. So we've got the exact same piece of information, that address, sitting in two totally different places.
Do you see it yet? Can you spot the huge critical flaw in having these two completely separate files? And there it is. The exact same piece of data, the student's address, is stored in two separate, disconnected files. This one simple duplication, well, this is the tiny seed from which all the chaos is about to grow. You see, that one simple flaw leads to this massive chain reaction of failures. So let's break down the 6 big problems that made this old way of doing things a complete and total recipe for disaster.
Okay, problem number 1, and it's the most obvious one, data duplication. And that duplication, well, it almost always leads to data inconsistency. It's just inevitable. When you have the same information stored in multiple places, it is only a matter of time before those copies don't match anymore.
And the consequences are totally real. So let's say a student moves. They do the right thing and update their address with the main office, so that file gets changed. But they forget to tell the bus department. The bus file is now wrong, and all of a sudden, the bus is showing up at their old, empty apartment. Not great.
And the problems just keep piling up. First, you've got data isolation. Think of it like this. Every department is stuck in its own little information bubble, and they can't easily share anything. Then you've got data dependence, and this one is a real nightmare. It means if you want to make one tiny change, like, say, adding a middle name field to a student's record, you literally had to go back and rewrite every single program that touched that file. Insane, right? And to top it all off, you had incompatible formats. A program written in one language, say COBOL, couldn't even read the files from a program written in another, like C. It was a total mess.
And maybe the most frustrating problem of them all was this one: fixed queries. You could only ask questions that a programmer had already thought of and specifically coded for, sometimes weeks or even months in advance. So if the dean suddenly pops in and asks, "Hey, how many students in the computer science department use the bus?" Well, you'd have to go and commission a whole new program just to answer that simple question. It was unbelievably rigid.
So with all this chaos, all this duplication, all this inefficiency, you have to be thinking, there had to be a better way, right? Oh, you better believe there was.
And that brings us to the hero of our story, the database approach. This was a completely new way of thinking, designed from the ground up to manage data intelligently using a really special piece of software.
And that software is called a DBMS, which stands for Database Management System. The best way to think of it is like a super smart secretary for all of your data. See, you don't mess with the files directly anymore. You just tell the secretary what you need, and it takes care of everything. It stores the data, it protects it from people who shouldn't see it, and it finds whatever you're looking for in an instant. And here's where the magic really happens. Because this approach solves every single one of the problems we just talked about. That data duplication? Gone. Because now there's one central source of truth. Data isolation? Fixed. Everyone can share that single source of data. That nightmare of data dependence? Solved. You can add that middle name field without breaking a single thing. It even lets you enforce rules, like an age has to be greater than 18, and it uses all these clever tricks to find one record out of millions in a split second.
So let's wrap this up. Let's do a final head-to-head comparison to make it absolutely crystal clear why databases didn't just win, they completely took over.
Okay, remember our bus problem? The student's address was totally different in two separate files, and that led to a big delivery mix-up.
Well, with a database, that literally can't happen. The address is stored in exactly one place, period. When it gets updated, everyone, the admin office, the bus department, you name it, they all see that same single consistent source of truth. Problem solved.
And what about security? I mean, just look at this. The difference is night and day. In that old file-based system, security was pretty much a joke. If you could get to the computer, you could probably get to the file. A database, on the other hand, gives you incredibly powerful, high-level security, letting you control exactly who can see or change what piece of data, down to the tiniest detail.
You know, this table right here really says it all. Where the old system had high duplication, the database controls it. Where it was inconsistent, the database is consistent. Where it was totally rigid, the database is incredibly flexible. No security versus strict access control. It wasn't just a small improvement, it was a complete revolution in how we handle information.
So, the next time you open an app on your phone, just think about this for a second. From your social media feed to your banking app, your photo gallery, your music player, pretty much every single one of them relies on a database working silently in the background, keeping all that chaos away.